Hello and welcome back to the virtual classroom. I'm your host, Dr. Olmsted. As you can see, today's topic is the scientific revolution. Now, before we begin, as always, take a moment, hit pause on this video, jot down that lecture outline to the right, and pay particular attention to those key terms at your left. Make sure you can identify the who, what, where, when, why, be able to connect them to each other and their larger historical significance. You got it? Let's get started. Now, we left off discussing, of course, the rise of absolutism, constitutionalism, and, of course, absolutism in Eastern Europe. But now we get to one of those seminal topics of European history. And most of you all know me, I'm not the biggest fan of European history. Like, there are certain aspects of it I enjoy. But as a whole, I see as a very egocentric or ethnocentric, view of the world. Where it's, hey, we're the greatest people alive, and everyone else, you all can suck it. But it is undeniable that there are kind of four major things, events that take place that completely alter and change the world. And it just so happens that all four of these things do take place in Europe. Their origins, their existence, their creation, their evolution, all takes place squarely within Europe and disseminates from there. And of course, the first one, of course, is the Renaissance. And while the Renaissance itself may not be the biggest deal on the global stage, it was that kind of first clog in the wheel that kind of got things from the first domino to fall. The second one, of course, is the Reformation. The Reformation is a world-altering, earth-shattering event because of all the religious wars that will develop, because of all just the changes in religion that occur. The third one is the scientific revolution. And I'll fully admit this is not the most fun topic to talk about or lecture through because it is a lot of people and just that slow incremental development. But the implications of the scientific revolution are, you can't overstate them. It's just impossible to overstate them. And then, of course, the fourth one, which will come up very soon in our lecture series, is, of course, the Enlightenment, which, again, completely radicalizes, revolutionizes the way we think about government, about each other, our relationship to others. And so these four major, events, the Renaissance, the Reformation, the scientific revolution, and then ultimately the Enlightenment. And so while I tend to be a non-huge fan of European history, again, it's undeniable. These events are important. So let's start talking about the scientific revolution here. Now, for centuries, we have lived in, at this point, what was called the medieval conception of the world. Now, primarily it was built on religious and theological thinking. Again, the earth being the center of the universe as detailed by the Bible, which, guys, I've read it. Nowhere in there does it say the earth is the center of the universe. But again, it's kind of a traditional idea passed down from the Catholic Church. As applied to politics, the political theory of the scientific revolution and background of it, medieval concept, was of course the divine right of kings, which we've seen thus far when we talked about the new monarchs and ultimately the absolutist monarchs. The thing is, though, is that all of society, whether it's traditions, economics, social, politics, all of it is largely governed by church view. And as a result of that, superstition plays a huge role in the lives of people. And you remember, defined anthropologically, religion is just a way to try to control the uncontrollable. And therefore, superstition, again, is common within many religions. Again, I point to the NBA at the free throw line or a batter or pitcher in baseball who spend, a minute doing through some pitch ritual. Now, even when we're getting to the early 16th century, scientific thought is still largely based upon this medieval idea. And they're all based in their view off the views of Aristotle. This was a very geocentric view that held the Earth was the center of a static, motionless universe. So yeah, there were other planets that had been discovered, but everything revolved around the Earth. Everything was kind of just in a stationary, circular position. What it boils down to is essentially science was a branch of theology. But there starts to be some small cracks in that general consensus. And it starts during the Renaissance, the early Renaissance, by sometime in the 1300s. We start having medieval universities that begin to provide the framework. You see one of the prominent ones there, Gresham College. And the reason that this is not, I guess, is the first huge step where everything opens up, but yet it's just the first domino to fall. And what happens is, at these universities, philosophy becomes an accepted discipline, in addition to things like theology, medicine, and law. And thus, medieval philosophers begin to develop a degree of independence from traditional theologians. So again, this is not overnight. This is not some radical transformation. It's not like Luther nailing 95 Theses. But rather, this is just a slow progression of events that leads to new discoveries that we kind of lump together as a scientific revolution. And so these universities begin offering, professorships in things like philosophy. They begin to establish professorships in mathematics, astronomy, in physics, which is considered natural philosophy. And so the philosophy department began to be subdivided into these new things like mathematics, astronomy, and physics. And we start seeing new scientific ideas being discussed at the university level. Then when you add in the Renaissance to that, this discovery of, old texts from the Greek and Roman days, you start seeing the rediscovery of ancient mathematics as well. And as much as the Renaissance was about, artistic and humanistic ideals, it was also very scientific. And then when you get to the age of exploration in 1450, you start seeing the need for new technologies, which we discussed previously. Things like the barometer, the thermometer. And while they're also developing new things, the sextant for ships, they also began to develop other new technologies like the telescope, the microscope, the pendulum clock. And Gresham College, as you see pictured there in England, the scientists who worked there also worked closely with the top officials of the British Royal Navy. And they became some of the leading shipbuilders and merchants, or helping the shipbuilders and merchants, develop better ships that would, navigate and, defend their territory. And so the result of all this early work, the scientific revolution will become the major cause of a brand new worldview during the 17th and 18th century. So officially, the scientific revolution is during the 17th, 18th century, but it has its antecedents back in the 1300s, 1400s. So let's start in the 16th century to show you some early changes before we get to the meat of it in the 17th century. It starts with Nicholas Copernicus. And of course, he will produce his seminal work on the revolution of heavenly spheres. And Copernicus proposes he actually postponed the publication of this book for fear of backlash in the scientific community. He dedicated the book to Pope Paul III. The problem is, again, he was very religious. He was afraid to publish his findings, and he dedicates to the Pope, but yet his work will be seen as heresy. because he develops what's known as the heliocentric view. He argues that the Earth is not the center of the universe, but rather it revolves around the sun. The sun is the center of the universe. Again, we take this for granted today. But this was a revolutionary thing that was seen as challenging the authority of the Catholic Church. And of course, this is still, early days of, the Reformation. But when this is coming on the heels of the Reformation and Martin Luther, you can understand why this is such a critical, possible blow to the Catholic Church. So it's a heliocentric view. The stars do not move, although the apparent movement was a result of the Earth moving. So up until this point, we've still gone back to the idea of this very static view of the universe, where the Earth was just stationary and everything moves. Well, he says, no, we're moving. And again, I've read the Bible, it's not in there. This was challenging the church's view. It's also directly challenged Ptolemy's view of a very geocentric universe, but it brought up the idea that the universe now seemed enormous, maybe even infinite. And it seemed to challenge the Genesis, the book of the Bible, Genesis, first book of the Bible. It challenged the Bible's book of Genesis on this geocentric view, its geocentric view. Now, both Martin Luther and John Calvin will condemn Copernicus' theory, and again, pointing to biblical passages that support the geocentric view. And initially, the Catholic reaction was less forceful because the church didn't always interpret the Bible literally. But by 1616, the Catholic Church will begin to proclaim the Copernican theory of heliocentrism as being false and persecute anyone who advances his views. So again, this is a very early thing. And while this itself is not life-shattering, yeah, actually it is life-shattering. This is worldview altering because we are completely revolutionizing the way we look at the universe. And if this is wrong, if this idea that we've had since the 2nd century, I'm talking 2nd century, you're talking 1,300 years, we've believed that the Earth is the center of the universe. And it seemed very small. In other words, it was just our solar system, that was it. But now we have an infinite possibility, and if that's wrong, what else can be wrong? And he helps set off a wave of new astronomy that begins to challenge our preconceptions, including Tycho Brahe. He became England's leading astronomer in the late 16th century. He built the first best observatory in Europe, collecting massive data on observations of the universe. And this data becomes the cornerstone for astronomy for centuries. Now, he initially did not accept the Copernican theory either. He believed that, all the planets revolved around the sun revolved around the Earth. Again, still holding that old biblical idea. But his data will actually end up proving Copernicus correct. And so while Copernicus gets it started, Brahe, despite not attempting to, thanks to his wonderful observatory, he'll be the one to actually scientifically, mathematically prove that Copernicus was correct. And Johannes Kepler, he's the first great Protestant scientist who was Brahe's assistant. And he's the one who actually took the math from Brahe's observatory and proved the Copernican theory. And he's the one who develops these 3 laws of planetary motion. Number 1 is the whole idea that you're just circles. He says the orbit of a planet are not circles, but rather they're elliptical. They're oval. He also say that number 1, 3 laws. Number 1, it's elliptical. Number two, they don't move at a uniform speed within their orbits. And number three, the time it takes to planet to orbit the sun is directly based on difference from the sun, is distance from the sun, which again, these are all common things. We just kind of make assumption. I mean, it makes sense. But again, this is very early on. So now we're going to jump forward then into the 17th century and talk about how these early astronomers, whether it's Copernicus, whether it's Brahe, whether it's Kepler, are going to help to set the foundation to revolutionize our understanding of the universe. And of course, the big daddy of them all, Galileo. He's the one who's going to develop the laws of motions by using the experimental method, using controlled experiments. And of course, gravity is a universal force that produces uniform acceleration. So, gravity. Law of inertia, an object that is in motion remains in motion until it is stopped by some external force. And using the telescope will validate Copernicus's heliocentric view. He was the first to use the telescope as a scientific instrument, not just observationally, but as a scientific instrument. And big surprise, he will become very controversial in Catholic countries. And by this point, even the Protestants are beginning to accept that this is a new worldview. But Catholics are still holding against this idea of all this new science and astronomy. And in fact, in 1633, the Inquisition of Pope Urban VII will force Galileo to retract his support of the Copernican theory. And he'll remain under house arrest for the rest of his life. Now, when it comes to, so they are all much about astronomy, right? Your first three are all astronomers. Galileo was himself an astronomer, but he begins to dabble into the next area of this, which is the actual science part of it. What you would normally think is science on Earth. Not just looking heavenly, but looking to the Earth. Because he's the one who's using the telescope as a scientific instrument in developing the idea of controlled experiments. So our first group are astronomers. Second group here, starting with Galileo, are actually scientists. The second one on the list is Sir Francis Bacon. And of course, he introduces what's known as the inductive method. So he formalizes the empirical method that had already been used by Brahe and Galileo. He takes what they've done, he builds on them, but he's the one who formalizes. And so he begins to create what's called the inductive method of scientific experimentation. So you begin with the inductive observation. Start with an observation. So you induce an idea, you produce an observation. Then you form a hypothesis, you use controlled experiments, and then you organize the data. So he argued that controlled experimentation would lead to new principles, universal principles, and scientific laws. This is all something you probably have already learned in your science classes. But to put it in a historical context, this is, again, life-altering. We're no longer looking to the church for answers here. I don't even say look to God. You're not looking to the church for answers. You're not looking at the Bible for answers to explain things around us. But rather you're looking, inward at these ideas of using scientific experimentation. Building on this inductive method was René Descartes. And he will just give a discourse on method. So Descartes developed a deductive method. So Bacon was inductive. Descartes was deductive. And he employs deductive reasoning to prove his existence. And of course, the very famous ergito or cogito ergo sum, I think, therefore I am. His proof depended on logic, in logic alone. And you might think, well, isn't this antithetical to science? And it's not. It says that science must start with clear and incontrovertible facts, and then subdivide each problem into as many parts as necessary, creating a step-by-step sequence. Now, whether you like it or not, he's the one who's going to develop analytical geometry In Cartesian dualism, you divided all existence under his dualism. He divided all existence into the spiritual and the material. And the spiritual could only be examined through deductive reasoning, i.e., logic. The material world is subject to experimental method. And it's the work of Sir Francis Bacon and Rene Descartes that we get our modern scientific method. So if you want to explore the material world that you can see, feel, touch, hear, smell, then you need to use Bacon's inductive method. However, if it's something you can't, if it's spiritual, you can only use logic. And so we get our modern scientific method from these two men, Sir Francis Bacon and Rene Descartes. And we get, so the modern scientific method is the inductive method plus the deductive method. And again, they make some general rules here, that there's a belief in the existence of regular patterns of nature. Use controlled experiments to record facts and verify hypotheses. You search for mathematical formulas to describe natural phenomenon. So there's regular patterns in nature. Use controlled experiments to verify hypotheses. And then search for mathematical formulas to describe natural phenomenon. And this is the cornerstone of Western society, that we embrace science to find answers in better people's lives, not to reject it out of some ideas where, well, I just have a feeling or a gut feeling. No, you're supposed to test and retest, control experiment, use both inductive and deductive reasoning, not just go on your gut. Now, one who kind of puts it all together is, of course, Sir Isaac Newton. He will incorporate the astronomy of Copernicus and Kepler, the physics of Galileo, into an overarching theory to explain order and design to the universe. And of course, universal gravitation, the natural laws of motion. They're evident in the movement of both heavenly bodies and earthly objects. Every body in the universe attracts every other body in the universe in a precise mathematical relationship. And since these laws are unchangeable and predictable, this is where it starts to be changing everything. Since these natural laws that he's formulated, since they are unchangeable and predictable, God's active participation in the natural world is not needed to explain forces of nature. Now, he's not saying God does not exist. He's not saying God is dead or God is not useful. But God's active participation in the natural world is not needed to explain forces of nature. In other words, if I were to jump off a desk right now, there's no need to say, well, God allowed you to fall like a leaf versus like a brick. But Newton says, no. There are predictable, there are tangible, recordable information that are natural laws that are unchangeable. They are predictable. This directly challenged the medieval belief system and becomes the foundation of the Enlightenment view of God known as deism. And something we'll discuss a little bit later, but just the brief view of deism. Deism does not deny God. Deism believes that God created the universe, generally speaking. And deists believe that, yeah, there's a creator God out there. However, they don't believe he has interaction necessarily in everyday life. It's not that you can't converse with him, but rather that God kind of created everything like a clock, and he wound the clock. And he wound it and wound it and wound it. It's going to do exactly what it's supposed to do for as long as that clock is ticking. It's going to tick. It's going to count the seconds, the minutes, the hours, the days, and it's going to keep on ticking without any interference from him whatsoever. And this becomes, again, this is a product of Sir Isaac Newton, because if everything is predictable and observable and unchangeable, all these different forces in nature, then, well, God can still exist, but God's not needed in everyday life. God's not needed to make sure that the water keeps on flowing today. God's not needed to make sure it's going to rain today. It's going to rain when, the conditions are right for it to rain. So you can see this is a big blow to the Catholic Church and, for instance, the Protestant Church in many respects as well, even though Protestants are more apt to accept it, generally speaking. Just for a fun fact for any of you who are taking the course, he also invented calculus. So let's talk about, switch gears. So we talked about physics and astronomy and general science, right? Math right there. What about anatomy and medicine? We'll see a number of scientists who begin to challenge the Greco-Roman medical views. Again, most of our view of medical, the anatomy, are based on Greco-Roman medical views of Galen back in the 2nd century, once again. And so Galen believed, or Galen's, Galen, he believed that he established what's called the humoral theory. He believed that disease was an imbalance in one of the 4 separate body humors. You see the division on your screen right there. So he believed the body was separated into 4 parts. He called them humors. And the blood, which would be broken down, is broken down into 4 body humors. One was blood, that could be either bright or dark red, the phlegm, the yellow bile, and the black bile. Now, in 1543, Andres Valesius, he will produce a work called The Structure of the Human Body. And it renews and modernizes a study of human anatomy. And he began to dissect and study cadavers, dead people. The problem is, this was a big deal. One of the reasons nothing had changed from the 2nd century to 1540, again, you're talking 1,400 years here. Nothing had changed in nearly 1,400 years because it was considered sinful by the church to, dissect and study a cadaver. It was considered unclean by the church, and it's desecration of the body. And as a result of that, people didn't do it. But Basilius will be one of the first to begin to do so again. And as he does, he begins to revolutionize our understanding and challenge Galen's 2nd century viewpoints. The one who really gets it going, though, is Anton von Leeuwenhoek. He becomes known as the father of microscopy because he develops some of the most powerful early microscopes. And he's the first to both see and write about things like bacteria, yeast plants, living organisms in a drop of water, or the circulation of blood in capillaries. He begins to see that, no, there's much more than we can't even see with our naked eye. And in doing so, he begins to launch a huge quest throughout Europe, especially in places like England, to begin to re-examine our preconceived ideas of the body and anatomy and sickness. As doctors were non-existent at this point in history. I mean, there are some who purported to be doctors, and there were some type of doctors. Talk about like those people wearing long masks during the plague. They were trying. But while England is not doing bloodletting, the old idea that, oh, you're sick, let's let some blood out, make you feel better, get the poison out. That idea is still based on the idea that, you have bad blood. hence high mortality rates. But once we start understanding bacteria, now again, this is not an overnight step. We're not going to understand actual viruses until late 19th century. Up to that point, we still believed in miasma theory that it was just bad air that caused things. But when we start to use the microscope, thanks to Leeuwenhoek, we begin to see that, hey, there's some stuff we can't see that maybe are causing us to be sick as well. And it begins to develop a number of Royal Scientific Societies, especially this one in London. Governments and monarchs began to encourage scientific inquiry. They begin to recruit scientists in scientific societies. And this is huge for a number of reasons. On the one hand, it furthers science. It also allows scientists from different countries to have a way to communicate with each other. So it brings the greatest minds in the world together in a way, albeit from a distance. And then one of the first royal societies in England was perhaps probably the most successful and prestigious, was founded in 1660, patroned by Charles II, who you heard about in our last couple lectures. But for a monarch, why would a monarch do this? Well, on the one hand, it furthers prestige of the state. Oh, we had this monumental discovery. We're the smartest people alive. It helps at the cutting edge of technology. So if you need new weapons or technologies to use for the state, this is important. And again, it usurps control from the religious sectors and gives monarchs control of a secular state versus a religious state. So for royal families to do this, it makes a lot of sense. Now, women will also have a pretty unique opportunity here. Again, much like we see in the Renaissance and the Reformation, the actual overall results are very incremental and not a lot of change, but some women will see new opportunities as a result of the scientific revolution. Remember, there's still largely informal education for women throughout the world. But a famous woman on the left, Margaret Cavendish, she will begin to offer observations upon experimental philosophy. She will attack the rationalist and empirical approach to scientific knowledge. Again, she'll begin to do what men were doing, but yet thought women could not comprehend. And so she'll be an early person that will offer some chance here. More important this for women was actually German women. 1 in 7 German astronomers was a woman, including Maria Winkelmann. She'll discover a comet, despite the fact that 1 in 7 German astronomers are women and she discovered a comet. She will be rejected for a post in the Berlin Academy because she's a woman. But what this did do, well, again, women don't play a major role. It does offer opportunity for some women. But what it does do, that's very important, is it begins to open a new debate over the nature of women. Remember, up to this point, it's just basically assumed women are the inferior, inherently based, prone to vice, easily swayed, emotional, and even, quote-unquote, sexually insatiable. But the scientific revolution, getting away from the biblical ideas, began to push new debates. And women began to join the debate in the 17th century and try to reject this view, despite the fact that largely science was still being used to perpetuate old stereotypes about women. The scientific revolution largely reaffirmed the traditional ideas about women's nature, that they were different and thus inferior. So while it will open opportunities and it will bring a fresh round of debate, ultimately the scientific revolution will not be that great for women, as it merely redefined, but yet still confirmed that women were indeed the weaker sex. This is all well and good, right? So we know these are really important long-term things, but what was the immediate impact of the scientific revolution on society? And one of the big ones was a separate revolution known as the agricultural revolution. But there's a strong connection between the agricultural and the scientific revolutions, namely because it was the spirit of experimentation that helped to accelerate the agricultural revolution of the 17th century. You got to realize, up until the 17th century, agricultural revolution, most of Europe had adopted what's called the open field system. So the old system is known as the open field system. And the idea of the open field system, you had 3 fields. You see on the left right there, right? Field 1, field 2, field 3. And there's a shared common field that to graze animal and use their, poop as fertilizer. And each villager shared the fields just enough for subsistence farming. Now, on the one hand, this was a great kind of communal effort so everyone could live. On the other hand, grain crops exhausted the soil. And so they began to experiment with things like crop rotation that dramatically increased production. They also crop rotation not only would not exhaust the soil, but when mixing different crops with the manure from the animals, it would create nitrogen storing crops in the soil, thus producing stronger yield increases. Using the scientific revolution, farmers in each part of Europe determined the best crop rotation for their fields. In other words, experiment. Maybe we shouldn't use wheat and, barley and then animals, but maybe we should let the animals walk through it, or maybe we should use a different crop like rye rather than barley. And by rotating certain crops, they found out better yields through better nitrogen storing crops. That's on the one hand. On the other hand, they also used the enclosure method by enclosing their fields off by using fences, which meant consolidating all these scattered crops into separate farms, each owned by one owner. This way, each one could do what was best for their type of soil. And maybe instead of growing wheat and barley, you grow wheat and potatoes, because potatoes are grown on the fallow ground because potatoes put nitrogen back in the soil. And of course, remember, potatoes are an import from the New World, so they were not available until after 1500. But using the spirit of experimentation, we also do create better agricultural methods as well, known as the agricultural revolution. Finally, we begin this debate over science and religion. Now, you see, the problem was for most of history, most of the scientific revolution, Catholics, for the most part, Catholic theologians left very little for innovation, little room for innovation or experimentation. Some Jesuits were an exception, and they were open to science. And after the Counter-Reformation of the Catholic Church, the church becomes even more hostile to science, and science will decline in Italy, not France. But Protestant nations become the leaders of the scientific revolution, especially England. Then again, some Protestant theologians are still very rigid, but overall, Protestants hold a more liberal view regarding scientific observations. Remember, there was no law or index of forbidden books, no Inquisition. And with the Protestant ideals of religion, which was an emphasis on individual search for truth and salvation, the idea of the individual, it allowed much more room for experimentation and observation. And so you see most often the top picture on your screen right now is often the Catholic view, versus the Protestant view early on was largely that we could overlap and find that scientists were just studying and analyzing God's creation. So, hey, God created all this. Why should we not understand it? Don't just say, well, it's out there, God got it, so we don't need to understand it. No, we can understand it too. And so the Protestant view was mostly that we're trying to understand God's view. But no, this begins to set up a debate that's going to rage into the present day over science and religion, or science or religion. But for now, I think it's a good place to stop. We'll come back next time and see where it takes us with the Enlightenment. But until then, take care and bye-bye.